Alright, what's up guys? In this video, I'm going to pick up some vector calculus here, and we're going to be evaluating another line integral by, or trying to find the work done by evaluating a line integral. So we're asked to find the work done by the force field f of x comma y comma z on a particle that moves along the helix, which is given by r of t, which is down here, and then this is the function. So I've done one example previous on how to find the work done. So this would actually be example number 2. And it never hurts to have multiple examples, because one example doesn't help anybody, because you can always tweak math problems. And even the slightest tweak to a math problem can change the dynamic of the problem. So it's always good to have multiple examples of the same thing. Okay, so how do we calculate the work? Well, we know it's just going to be f dot dr, and remember that's just equal to the integral from a to b, and it's just going to be f of r of t dot r prime of t. So note, it's just the dot product, basically. And again, we've done this before. So we know as well that t is going to be between 0 and 2 pi. Okay, so let's go ahead and do it. So the first thing we need is the first derivative. So let's get that out of the way. So we need to take the first derivative of r of t, so we just take the derivative of each component. And so in that particular case, we get -7 sine of t, comma, 7 cosine of t. And then it looks like we'll just get 7. All right. Now what we need is f of r of t, so let's get that. So we just got to plug it in. So it looks like we're going to have 7 cosine of ti plus 7 sine of tj. And then we'll have plus 6k. Now I need the dot product, so we can try to get that right now. And we already have our first derivative, so I'm pretty sure I'm going to run out of room taking the dot product, so I may have to go down to the next line. Alright, so we know that 3 times 7 is 21, but again, we're taking the dot product. So in this particular scenario, and we're taking the dot product with our r prime of t, by the way. All you got to do is kind of follow the formula there. So it looks like we'll get -21 times 7 sine of t multiplied by cosine of t. We'll then add that to positive 21 times 7 sine of t multiplied by cosine of t. And then it's going to be plus 42, because 7 times 6 is 42, so this would be plus 42. And basically what this is going to give us is just 42 after we simplify it. So f of r of t dot r prime of t, which is our dot product, is just going to give us 42 here. And I will leave the algebraic simplification to you guys. I'm pretty sure you guys know how to do that. Okay, so, and again, we know we're just going to get 42, because -21 plus 7 sine of t times cosine of t plus 27, or excuse me, plus 21 times 7 sine of t cosine of t is just 0. And we just left with the 42, just in case you were wondering. So now what we have is w, which represents the work. Again, it's going to be from 0 to 2 pi. And we're integrating this constant with respect to t from 0 to 2 pi. So that's going to be 42 multiplied by t from 0 to 2 pi. And this obviously will give us 84 pi. And that's your answer. So your final answer here and the work done by this force field, which will denote W, is simply going to be equal to 84 pi. And that is your answer. All right, so hopefully that made sense. That's just another example that I wanted us to quickly look at. So, like I said, you can let me know if you have any questions about anything, and we can talk about it. So I'll see you guys next time.